Okay, we're gonna practice incomplete dominance and codominance. A red snapdragon and a pink snapdragon are crossed. What is the chance of having a white snapdragon? Well, you should know from the last lecture that a red snapdragon is big R, and that a pink snapdragon is big R, little r, because the big R is not completely dominant over the little r. What is the chance of having white snapdragons? Well, white snapdragons was little, so it would be a 0% chance. A person with wavy hair is crossed with another person with wavy hair. Well, in the last PowerPoint, you learned that wavy hair was due to incomplete dominance. It's the mixture of curly and straight. What are the possible genotypes and phenotypes? We're talking incomplete dominance, and we're talking wavy hair, so big T was curly. Big T was wavy. And little t would be straight. We would have straight hair. So again, incomplete dominance, one gene is not completely dominant over the other gene, so they have to blend. In this case, you have to think of the big letter as not completely overpowering the little letter, so they make a mixture. Okay, last question. Which of the questions follows Mendel's experiments? Well, if you look at question 2, big T crossed with big T, that would be an example of his F1 generation, because you have a heterozygous crossed with a heterozygous. Because by now, you should know that Mendel's first generation was his P1 generation, pure crossed with pure, homozygous dominant crossed with the homozygous recessive. Those two were made to have sex and had babies. The babies were called the F1. The F1 cross is then a heterozygous crossed with a heterozygous, which then those babies from that cross are known as the F2 generation. So by looking at crosses, you should be able to tell if it's one that was similar to what Mendel did or doesn't follow his experiments at all, or just a random cross. Okay, now codominance. If you remember from the last lecture, a roan cow, it has both red and white fur. So a red cow and a roan cow have babies. So let's get the cross. What are the genotypes and phenotypes of the babies? Big R is red, just kind of like flowers, except this is codominance. Big R and little r would be roan, which is red and white fur. So this time they're both dominant. That little r cannot be overpowered by that big R, and the big R cannot overpower the little r, so they both show up. A black chicken and a white chicken are crossed. What are the genotypes and phenotypes of the kids? What's the chance of having a black baby? So black chicken is crossed with a white chicken. Again, codominants, they're going to have chickens that all have black and white feathers. What is the chance of having black feathered chicken? 0%. That big B does not overpower the little b in this case. They work together and they both show up. Okay, the last thing we have is a white chicken and a chicken with both black and white feathers have kids. What's the chance of having a white chicken? So a white chicken, and then we have black and white chicken. I'm running out of room. Okay, what is the chance of having white chickens? Well, if you can see that, it's the bottom two, the little b, and it would be 50%. Okay, one thing you do not want to do is to confuse incomplete dominance, codominance, with what we've been doing, the complete dominant versus complete recessive. Ruminant chickens, the cow fur coat, codominance. Incomplete dominance, the snapdragons, hair texture. You're going to have to know those. I'm not going to tell you that they're incomplete dominant or codominant on the test. And then there's something called multiple alleles. More than just two alleles for every trait. And we've talked about this earlier. So far with Mendel, it's always been round versus wrinkled, yellow versus green, constricted pods, inflated pods. You've had this or this, tongue rolling, non-tongue rolling. There's just been two options for every gene. In real life, it's not that easy. So there's traits out there that have multiple alleles, and there's many traits out there. But a few would be blood typing. There's the A allele, the B allele, and the O allele. Your hair color, your eye color, your skin color, we've talked about that before. There's more than just the two options for the gene. Which then, them coming together, all those different variations, give us the variety that we have in life. And then to make it even more complicated, there's something called polygenetic inheritance, or polygenetic trait, which poly means many, genetic referring to genes, so it would be a trait controlled by many genes. Polygenetic trait, a trait controlled by many genes, as it's showing you here. You have an A gene, a B gene, and a C gene, and how they come together gives you the many options. So not only can you have many genes involved, you can also have multiple alleles. Another way of showing you this, let's say we have, there's mom's genes, or dad's genes, or let's call them chromosomes. So on the left we have mom's chromosomes, on the right we have dad's chromosomes. We have more than one gene involved. Let's say there's a gene sitting here, one there, and one there. So that gene that you get from dad. Okay, so we have 3 genes, and let's say from the mom you got, for blonde hair, maybe red, and from the dad, brown, brown, brown. So you inherited 3 different alleles, because your hair color is due to multiple allele. Hair color, and I think it's actually due to 4 genes, but we'll just say 3 genes, and all those combinations, you'd probably have something like light brown hair. So it gets very, very complicated because of multiple alleles and your traits controlled by multiple genes, more than just one from mom and one from dad. Like I said, hair color is something like 3 or 4, and eye color is also something like 3 or 4 genes that control those.